Sorry I couldn't be with you guys in class today, but I want you to watch this video and make sure you're taking notes on the video so that way you're understanding how to graph equations when they're not in slope-intercept form. So make sure you're paying attention and make sure you're writing everything I write down. Okay? So at the top of your page, go ahead and put in the title of these notes. And the title of these notes is Graphing Lines Not in Slope. That's not how you spell slope. Slope, intercept, form. So that's the title of our notes for today. So make sure you write that at the top of your paper. Now, the goal of today's notes, so our goal is for each of you, so all the students should graph lines given in standard form. So you should go ahead and write down this goal as well, okay? It's really important that whenever you guys are taking notes, whether it's in my class or another class, they always have the goal or the objective of whatever you're doing written at the top of your page, okay? Now, we're going to use our notes in Cornell style. So here's what that means. We're going to break up our paper into two sections. So the first section should be pretty small, and we're going to call that section our question section. Okay? And the second section, the larger section, is our notes. So here's what you're going to do. When you're taking notes today, make sure that all of your notes appear in this section. When you're done, you're going to go back and help you and ask some questions and fill them in the left-hand side, okay? So everything I write should be in the notes section of your notes, and everything you write should also be in this section. When questions arise, that's what you want to put in the questions column. So when I come back on Wednesday, if you have any questions in this column, I can answer them for you, okay? So you don't forget your questions, make sure you write them down. So here we go. So far in this class, we've only graphed equations in slope-intercept form. And we know that slope-intercept form is y equals mx plus b. And slope-intercept form is really handy, again, like we talked about last week, because it gives you the slope and it gives you the y-intercept. Now, graphing equations in this form is really easy to do because it gives us all the information we need, but every equation we get doesn't always look like this, okay? So when equations are in standard form, okay, our equations will look something like this. So I can write like 2x plus 3y equals 12. So if I want to graph something in standard form, right away you should notice that we have some differences in this type of situation than in our y-intercept form, or our slope-intercept form, excuse me. So first of all, in this situation, in standard form, our x and our y terms are on the same side of our equal sign, okay? In slope-intercept form, our y and our x are separated by our equal signs. So when we have an equation in standard form, we have two options to graph, okay? So the first option, then, let me just extend this line a little bit. So we have two options, okay? So our first one is to isolate y, and our second one is to find both intercepts. Okay, so I'm going to show you both options today, and then you can use whichever one you like better to help you in graph these types of equations. Okay, so let's just move this down a little bit so we can keep going. Again, I'm just going to keep extending my line down the page. So let's think about isolating y. Okay, so option one, isolate y. Okay, so just to help us follow along, I'm going to rewrite my entire equation. So my entire equation is 2x plus 3y equals 12. So to isolate y, so I need this term by itself, I have to do two things. I'm going to have to get rid of my 2x, and I'm going to have to get rid of this 3. So hopefully you remember from 8th grade that if you have an extra term that you want to get rid of and that term is positive, you have to do the opposite of adding. Okay, so the opposite of addition is subtraction. So I would subtract 2x from both sides. Now, that would leave me, I'm going to bring down my 3y term, so that would leave me with 3y is equal to, and now I'm in a little bit of a conundrum, right? Because 2x and negative 2x and 12 are not like terms. So I don't really know what I'm going to do with these things, but because they can't be combined, I literally just need to write negative 2x and a positive 12. So negative 2x plus 12, okay? And then, so I now have my y term by itself, but in slope-intercept form, my y is completely alone, okay? It's completely by itself here, and in the form of the equation I have a 3 in front of it. So again, think back to 8th grade math. When you have a 3 in front of a y term, you divide. So I'm going to divide everything by 3, okay? Everything needs to be divided by 3. So these 3's are going to actually divide to be 1. Okay, so I don't ever need to write 1y, I can just write y. And then I don't know what negative 2/3 is, but I'm just going to leave it like that because fractions are my friends. Plus, and then 12 divided by 3 is 4. So now I have my equation in slope-intercept form, and I can graph it. Okay, now, that was option 1. Let's talk about option 2. So, when we think about option 2, we're going to look for our intercept. So let me go ahead, I'm going to continue to extend this line. So option 2. Okay, so option 2 allows me to look for my x and my y intercept. So again, just so we're on the same page, I'm going to rewrite my equation that I'm given. So hang on, using intercepts. Okay, so I'm going to rewrite 2x plus 3y equals 12. So I'm going to use my intercepts to figure out, or I'm going to use my equation to find my intercepts, excuse me. So here's what I need to remember. So if I'm given an ordered or coordinate plane, I know that this is my x-axis and that's my y-axis. Now I also know on my x-axis, my y value is 0, and on my y-axis, my x value is 0. Okay, so using the intercepts involves two things. Step 1 is to plug in 0 for y. 1. Plug in 0 for y. Now when I do that, that's going to give me 2x plus 3 times 0 equals 12, which would give me 2x equals 12. So now I need to think, okay, what value of x can I multiply by 2 to get to 12? So you can either know how to do that in your head or think back to 8th grade and just divide both sides by 2 and get that x is going to equal 6. So this is my x-intercept. So if I'm graphing this, 1, 2, 3, 4, 5, 6, I'm going to have x-intercept right here at 6. Okay, that's my x-intercept. So then I need to find my x-intercept, or I found my x-intercept, so now I need to find my y-intercept. So when I do that, I'm going to do the same thing I did for number 1, except instead of plugging in 0 for y, I'm going to plug in 0 for x. So that's going to give me 2 times 0 plus 3y is going to equal 12. So 2 times 0 is 0, so that goes away, and I'm left with 3y equals 12. And again, I'm going to think back to 8th grade. So I'm going to divide both sides by 3 and get y equals 4. So that is my y-intercept. And then I can go back up to my graph and put my ordered pair on my y-intercept. Put my point on my y-intercept. And then last but not least, draw my line. Now, notice that in slope-intercept form, B is your y-intercept, and y is your y-intercept here, okay? So both these values of my y-intercept are the same. Okay, that's because these two lines are the same. If I graphed this line in slope-intercept form, or I use my finding my intercepts method, I would have gotten the same exact line. So your y-intercepts should match, right? They're both 4. Good, that's what we want. So go ahead now and write down any questions you have on this side of the page. And the substitute is going to give you some work to do on this for now, okay? Please go ahead and do that. I will collect it on Wednesday. Again, if you needed to have been taking notes during these videos, so I hope you were doing so.